Hey, good morning, everybody, and we are going to go through Mastery 4 here on what's called factoring polynomials, okay? So let's go through all the different techniques. Let's start off by factoring out the common factor out of each expression, okay? So take a look at this. Look at the coefficients here, the 54, the 18, and the 24. You got to think, what divides them all? So you got to start thinking, okay, does 2 divide them all? And the answer is yes, because they're all even. But does something else divide into them, okay? So let me see, starting with 18. I know that 18 has factors. Let me see. 18 is 2 times 9, 3 times 6, and 1 times 18. That's for 18 right there. 24 is 1 times 24. All right, 2 times 12, 3 times 8, 4 times 6. All right, so what common factor do they have? In 54, well, let me see, that's 1 times 54, 2 times 27. All right, 3 times probably 18, 6 times 9. And is there anything else? 6, 9, 12. That's probably, yeah. So what factor do they have in common here? What's the greatest common factor? And I noticed that they all have 6 as a common factor. All right, the question is, do they have a higher common factor? And also, they also have one k in common. They all have a k. Nothing higher than k. Nothing, they don't have k squared in common or k cubed, so they have a k in common. So I need to factor out a 6k. So let's try that. So 6k, all right, times something, all right? You always factor it into what's called a factor pair, all right? Something times something gives you the original polynomial. So when you factor it out, you divide it out. So what I'm going to do is I'm going to divide all of these by 6k. And I'm going to put the result here in the quantity here. So that's when you factor it out, you divide it out. So 54 divided by 6 is 9. K cubed divided by k is k squared. And then 18 divided by 6 is 3. K squared divided by k is k. And then k divided by k is, these cancel out. And 24 divided by 6 is 4. So plus 4 right here. Okay, and that's called factoring out the common factor. Here's the GCF right here. All right, the 6K. That's what it means by common factor. Common factor is right here, GCF. And of course, you got to multiply by something to get the original polynomial. So you check by distributing back through. So 6 times 9, 54. K times k squared is k cubed. Distributing the second time, 6 times 3 is 18. K times k is k squared. And lastly, 6k times 4 is 24k. So distribute back through to check. Now, on the number 2, they don't have a k in common, so I can't factor out a variable. So I've got to be thinking, what divides 40, 72, and 48? So they're all even, so 2 does, so the question is there a bigger common factor? So 40, the factor pairs are 1 times 40, of course, 2 times 20, 3 doesn't divide into 40, about 4 times 10, 5 times 8. Let me see, anything bigger? Probably not. Okay, now 72, so 72 is 1 times 72, 2 times 36, 4 times, so 72 divided by 4, divides once, remainder 3. All right, so 32, so 18, so 4 times 18. All right, 8 times 9. So far, I see a common factor of, 4. 4 is a common factor, but is it the biggest one? I don't know. So 48. So 1 times 48, 2 times 24, 3 times 16, 4 times 12, 6 times 8. So we got those factors there. Anything bigger? Probably not. So what is the common factor there? So I see a 4 in common. Is there anything bigger than a 4 that's in common here, common factor? So let's try to factor out and let's check. So 4 times something, right? Divide them all by 4 and put the result inside. So 40k cubed divided by 4 is 10k cubed, minus 72 divided by 4. Well, that's 18, as we talked about here, so 18k. And then 48 divided by 4 has got to be 12, so minus 12 here. All right, and obviously I didn't pick the greatest common factor because I just noticed here that 8's a common factor. So really we shouldn't have done it this way. So let's factor out the 8. So let's divide them by 8. Okay, the biggest common factor. All right, I knew that because there's still a 2 as a factor here, so I didn't factor out the greatest common factor, just a common factor. So let's do it again. I did that on purpose, by the way. So divide them by 8, you get 5k cubed here, minus 72 divided by 8 is 9, so 9k. 48 divided by 8 is 6, so minus 6. All right, and now we have the GCF out. Okay, we factored out the common factor, the greatest common factor. Okay, now when it comes to third degree polynomials like this right here, we're going to factor by grouping. Okay, so factor by grouping. And what we're going to do is we're going to look at the first two terms and factor out the GCF. So here, out of these two terms, I notice that 7 divides both of these numbers here, 49 and 35. I know this, they have an x squared in common, so I'm going to factor out a 7x squared. So you divide both of these by 7x squared. And what do you get? You get 7x minus 5, okay? And then out of 56 and 40, these next two terms right here, I want to factor out, what divides both of those? How about an 8? Okay, so let's factor out a positive 8. So that'd be, divide both these by 8. So I get 7x here minus 5. And notice that we have something in common, okay? Now the common factor is 7x minus 5. So let me highlight that. So we're going to start off with 7x minus 5. That's the common factor, times the remaining term, 7x squared plus 8. So 7x squared plus 8. And we now have a factor pair. So when you factor a polynomial, you factor it into a factor pair. You can check all your notes. We did a ton of these. All right, so you change a third degree polynomial with 4 terms into a factor pair. That's what it means to factor into a product of 2 terms. This is a product of 2 terms. Same thing over here on the right in number 4. We want to factor out the GCF here. So I notice that 8 divides into 56 7 times and 8 divides into 32 4 times. So let's factor out an 8. And I notice they have a v squared in common, so factor out 8v squared. So divide them both by 8v squared and you get 7v minus 4. And then here's what divides. 5 divides into these. So factor out the 5 and you get 7v minus 4. These binomials will always be the same in this technique. All right, so factor it out. 7v minus 4 times the remaining terms, 8v squared plus 5. All right, now let's factor some trinomials and play the factor game. So here we go. We want to figure out, okay, what two numbers multiply to 10, 10 times 1 is 10, and add to 7. So here we go. So what two numbers multiply to 10 and add to 7? Well, we know that 1 times 10 is 10, but 1 and 10 don't add up to 7. But 2 times 5 add up to 7, so, and they also multiply to 10. So what we're going to do is factor by grouping here. All right, sorry about the interruption. Here we get back to it here. So let's factor by grouping here and split the middle term. So we're going to have n squared plus 2n plus 5n, all right, plus the 10, right? 7n was split into 2 terms. 2n plus 5n is 7n. All right, so you just split the middle terms using these factors right here. And now you factor out the common factor, so factor out the n. 5 is a common factor out of the next group, so factor out the 5. So notice that the common factor is n plus 2, so we start off with that. And so you have n plus 2 times the remaining factors right here, n plus 5. All right, and now you have what's called a factor pair. All right, you factor the trinomial into 2 factors. All right, if you multiply this using FOIL, you will get n squared plus 7n plus 10. All right, so let's continue here. So what two numbers multiply to 12, negative 12? 1 times negative 12 is negative 12, and then, well, the middle coefficient is 1. So what two numbers multiply negative 12 and add 1? Well, they happen to be negative or positive 4 and negative 3. So 4 times negative 3 is negative 12. 4 plus negative 3 is 1. So here we go. We're going to split the middle term. So notice that I just used the factors here. All right, I split that middle term. 4x minus 3x is obviously 1x. And then minus 12. All right, out of the first 2 terms, x is the common factor. Out of the next 2 terms, they're both negative, so I'm going to factor out a negative 3. And then notice the common binomial is x plus 4. So we're going to start with that, the common binomial. and then multiply by the remaining terms right here, your x minus 3. And you could check this. You can multiply this, so check using FOIL. And you will get that trinomial up top, x squared plus 1x minus 12. All right, so you got to play the factor game, okay? And here we go. What two numbers multiply to 9 and add to 6? Well, let me see here. 3 times 3 is 9, and 3 plus 3 is 6. So x squared plus 3x plus 9. Factor out the x here. Factor out a positive 3, so put plus 3 here, times x plus 3. And then notice that the common binomial is right here. It's x plus 3. Multiply it by the remaining terms, x plus 3. So, and then check using FOIL. Here, it's not a trinomial, so you don't play the same game. You just notice there's the GCF. So factor out, all right, GCF, which is x. So x times what? Well, if you divide them both by x, x squared divided by x is x, plus x divided by x is 1. And then you check by distributing back through. Okay, and you'll see that x times x gives you x squared, and x times 1 gives you x. Now we got to play the factor game a couple more times down here. So here we go. 2 times negative 10 is negative 20. And then what two numbers multiply to negative 20 and add to 19? Well, the factors are of 20 are 1 and 20. Make one of them negative. 20 plus negative 1 is 19. So that works. We don't need to use 2 and 10 and 5 and 4, okay, because they don't add or subtract up to 19. So we've split the middle term. I'm going to start off with a plus 20r here. All right, minus 1r. You can put 1 there if you want. All right, and then minus 10. Factor out a 2r here, which is in common, so 2r times r plus 10. They're both negative here on the third and fourth terms, so factor out the negative 1, and you get r plus 10. Distribute back through, you can check that, by the way. And the r plus 10 is in common, so we're going to start off with the r plus 10, the common factor. Multiply it by the remaining terms as we did in all the previous examples, and we get 2r minus 1. So your factor pair looks like r plus 10 times 2r minus 1, and you can check with FOIL, and you can check your answer. Okay, last time. Here we go. So what two numbers multiply to negative 6? So always multiply here and then add to negative 1. So let's try negative 3 and 2. Negative 3 times 2 is negative 6. Negative 3 plus 2 is negative 1. So let's split the middle term. So use these factors here, negative 3 and 2. Let's factor out a 3x here, because that's in common. Factor out a 2, because that's in common. And you'll notice that x minus 1 is your common binomial, so we're going to start off with that. I'm just being consistent. Multiply by the remaining factors here, the 3x plus 2. Now, I probably went a little too fast. So what you guys can do is to rewind it, listen to it a couple times, go through it, practice, all right? So check your work, practice, and go through it and try to develop some mastery here because we've been working on this for the last 3 months. All right, this factor by grouping and factoring trinomials. So major concept in Algebra 1 and 2, all right? And also later on in Calculus 2, you see the techniques as well. So get good at it, practice really well, and I will see you on your final. This is Mr. Ainsworth. I'm out of here. Bye-bye.